Hey y'all, hope you're well. It's Dr. D here. I want to talk to you today about summary stats in Excel. So we're still relatively at the beginning part of this course. Want to learn about how to, we learned a little bit about normal distribution stuff, norm.s.dist and norm.s.inv. What I want to talk about today, let's see, which is these required? 3, 4, 5, 7, and 8. Pick one of these. 7 here seems good. All right, so let's look at this attend worksheet. Both 7 and 8 are both addressing kind of the same thing, which is how do we get means, how do we get standard deviations from a data set. And this attend sample we're going to look at. 10. And look down here. Actually, while we're here, there's a quick shortcut key I want to teach you. If you use control page down and control page up, that lets you navigate across sheets in Excel without having to use the mouse. So you can see over here, if I press control page down, that lets me scroll through control page up. So this attend data series is the one I wanted to show you. Data set is what I want to show you. You can see this attend variable is the number of attendances. Each row is an observation that corresponds to a person or a student. We've got a term GPA. I don't know what GPA is, primary GPA, maybe within their classes or their core. ACT score, their final, the number of points they got on the final. Attend rate, just a percentage. Homework rate, whether they're freshman, sophomore, how many times they skipped. And I think if you look, skipped and attend look like they always add up to 32. So skipped is just kind of the additive inverse of attend. Standardized final and their final percentage, which again is a score out of 4 their final. So if we look here, 7A just wants to know what is the sample size of the attend sample. So this is a good chance to learn a little bit about some variable or some formulas. In Excel, there are a few ways to count. Count is one of them. It only counts numeric data, which is good to know. Count A is another one. This counts any alphanumeric data, so just non-blank cells. Alphanumeric. So if you have categorical data, then count A is good. Then there's also Countif, which we won't really get into today, but this lets you count given particular conditions. And then maybe my favorite, because it's incredibly powerful, it's Countifs. And so these are both conditional. Countifs just lets you express multiple conditions, and so it'll count the intersection of those conditions, right? Which are the things that satisfy all the criteria that you specify, which is super useful later when we get into like contingency tables and stuff. In any case, since all we need is the sample size for the attend sample, what we need to do is just pick a column that has data that's not that's non-blank throughout, and use count. If we pick numeric, either way, let's use count A just to be on the safe side. If we use count A here, and then just what I did was I clicked on the first one, and then I pressed, if you recall from a previous video, Control Shift down, the down arrow. So Control Shift and down brings us down all the way to the bottom while expanding it to a selection. So Control Shift down, and so you can see what I'm doing then is I'm just counting every cell here. It should be 680, and sure enough, that's 680. Let me get that formula out so you can see it. You don't have to count that variable, right? So if I wanted to go in here and change this to a different column, like B, it would still give me the same result, right? Because it's just counting one variable for each observation. That's the number of, that's their sample size, so that's little n. So in this case, n is 680. What is the mean number of times students attended class in the attend sample? Well, in Excel, the way we calculate a mean is equals average. And this is going to be our sample mean. So we've called this X bar before, right? It's our sample mean. And that's what we're trying to find out here, right? So in all the rest of the questions that we've gotten so far, they've given us means and standard deviations, albeit population means and standard deviations. If we need to find our own mean, equals average gets us there. And generally speaking, it'll give us the sample mean because we don't have a data set that has a population. So let's see, equals average, and then attendances, right? So the attendances is the first column here. Again, I press Control up to get to the top. Now Control Shift down gets me back down to the bottom. And it should be that number. Yeah, that's correct. And there's the formula again. So that's how I calculate the mean for this group. what is the standard deviation of attendances in the attend sample? All right, now there are two standard deviation formulas in Excel. One of them is for sigma, and that's equals STDEV.P. And one of them is for S, and that's STDEV.S. And the difference is that this P stands for population, and this S stands for sample. And you can see that this says the attend sample. And surely 680 there, most places there are more students than that, or more potential students. And so this is a sample. And so the one we're going to want to use is the sample standard deviation. STDEV.S. Oh, I press tab, by the way. Once it's filled in, that inserts that parentheses. And then I press control page down, control page down. Again, they want the standard deviation of these attendances. So control shift down, close parenthesis. And that's the answer I get here. I press equals, and I point here to say just bring that number over. Sure enough, that's the standard deviation. So, within this sample, we've got a mean X bar of 26 with a standard deviation S of 5.45 in terms of our attendances. What is the mean score on the final exam in the attend sample? Okay, again, this is a mean equals average, tab, control page down, control page down. Score on the final, I'm going to assume that they just mean this final rather than the standardized final or final percentage. So the average score on the final, I'm using the arrows to get to the top, to get to E2, and then control shift down gets me to the bottom. Close parenthesis, enter. That's the formula I'm using. Let's see if it's correct. Sure enough, that's the correct answer. And then finally, the last question here, what is the correlation between number of class sessions attended and final exam score in the attend sample? So this is asking us to calculate a correlation coefficient, which if it's been a while, let me just briefly remind you how correlation coefficients work. Let's see, correlation coefficient, let me change colors finally. So correlation coefficient, sometimes called rho, R-H-O, is somewhere between -1 and 1, and it captures the strength of a linear relationship, strength and direction of a linear relationship. Now that can be tricky. There are some cases where you can have things that are uncorrelated in this sense that are definitely related, go quite that high. So over here we would have perfect negative correlation, and that's the case where perfect negative correlation you'd have as if this is your this is your x variable and this is your y variable. Perfect negative correlation is when x goes up, y goes down. So that's a perfect downward sloping relationship. Over here we have perfect positive correlation. That's a row of 1, or an R of 1 sometimes, called an R. And in that case, as x goes up, y goes up. And actually, the thing here is not the 1-to-1 relationship, or it's that it's downward sloping and that it's a straight line, right? But all of these are perfect negative correlations. And a perfect positive correlation is just any upward sloping line that has no scatter to it, the real thing. The difference here is that if it's not perfect, oh, sorry, I'm covering that over. If it's not perfect, a negative correlation that's non-perfect might look something like this. So that is a negative correlation, but it's tight, right? They're close, but it's not perfect. And then similarly, a non-perfect positive correlation, and I'll make this one looser just for demonstration purposes, right? This would be an imperfect positive correlation. Generally speaking, as x gets larger, it also gets larger, but that one's much noisier. The tricky thing about zero, a correlation of 0, is that you could have a very tight relationship that's just nonlinear. So if you had something that looks exactly like that, that's going to have, if you drew a straight line through it, it's going to have a slope of 0. So it's no uncorrelated in some sense, but there is a relationship. In any case, if we assume that there's a linear relationship, this tells us something about it, the direction and strength. And our expectation is probably that the more you attend, the higher you would do on your final, but maybe it's not that close, right? Oh, in Excel, actually, before I type it, I'll write it for you. In Excel, the formula we use to find a correlation is equals CORREL, and then you have to feed it 2 arrays, or 2 stacks of numbers, essentially. Array 1, array 2, and then close parentheses. It's critical that there be no missing data, that there be no non-numerical data, and that there be, yeah, I guess that's it. No missing data. Oh, and that the two arrays be the same size. That's the third thing. So let's see, equals CORREL. Array 1 is going to be, they said, between the attendance and the score on the final. 0.14003. So it is positive, but it's pretty weak correlation. Actually, just because I'm here and I'm curious, I want to see if we do a correlation between attend rate and final. Does that give you the same result? It does, right? So it turns out that because attend rate is just a what's called an affine transformation. In this case, there's no slope difference, but it's just scaled to 100 to a different degree. The correlation between any two variables that are capturing the same underlying relationship is the same. Similarly, if we look at the let's look at skipped, because that's the opposite, right? So that's negative of it, and final percentage. Look, that's just negative. The only reason that's negative is because skipped is perfectly linearly inverse, right? It's additively inverse with attendance. And so you can see that really this gets a little into what correlation is capturing. It's capturing the relationship between differences in scale from across a distribution. It doesn't matter if you're counting it in terms of number of missed days, or whether you're counting it in percentage of missed days or number of attendances. The underlying relationship, except for the directionality, is the same. So that correlation, regardless of which one it is, I mean, this is the one it's actually asking for, between number of class sessions attended and final exam score. But it turns out that using final exam score, or final exam percentage, or number of attendances, or percent of attendances, it's all going to give you exactly the same correlation, because correlation is about the strength of the underlying relationship, not about the units you're using in terms of points or percentage, which I think is pretty cool, and it's a neat way that you can visualize that. Okay, so that's how you find averages, standard deviations, and other summary statistics from another data sheet in Excel. And as we go along in this course, you'll see more and more of this. Problem 8 is very similar, but instead of using the attend worksheet, you're going to use this people boxes worksheet. One thing to note here is that it can be hard to read, and this is true for a lot of data, and so I highly recommend using the arrows. Don't make them wider than they have to be, right? If you make these wider, they just get really ugly, right? So if you make that too wide, it'll get really big, and some of them get super long. So I would use the formula bar up here as your way to kind of use it as like a magnifying glass to see what's going on here, and then use that to find the variables that you need to do number 8. I hope that was helpful. If you have any questions, I'm always available. Please get in touch, and I'll do whatever I can to help. Thanks, and see you guys next time. Bye.